What's up, Algebra 2? Okay, so I want a few examples of the worksheet that you guys are going to be working on, pretty much it's this. I'm going to give you quadratics in different various forms, sometimes standard form, sometimes intercept form, sometimes vertex form, and I need you to be able to find some key points, and that's mainly it. So the key points of a quadratic, again, are going to be x-intercepts, y-intercepts, and then last but not least, the vertex, okay? So here's a couple scenarios of what could happen on the worksheet, and hopefully this helps you out if you are having trouble. So here's a standard equation. So the first technique I'm going to show you is to get the y-intercept. I think the y-intercept probably is the easiest thing to get, and the y-intercept is found by just putting a 0 into each of the x's that you see. So I'm going to start by doing that. So I'm just going to go ahead and go y equals 0 squared plus 2 times 0 minus 8. So 0 squared, 0 plus 0 minus 8. So you're going to just end up with y equals negative 8. So the y-intercept in this equation is just simply y equals negative 8. Fun fact, after writing this down, again, this is a 0 because x is 0, I got negative 8, that's how I write my y-intercept. But fun fact is the number without an x in these equations always is going to be the y-intercept because, again, when you plug the zeros in, everything goes away other than that, plain old number. So just a heads up if you're doing those, especially in standard form. Now, let's talk about x-intercepts and vertex. Now, I have two options at this point. With the standard form equation, I can go the route of completing the square, which is what we talked about last time. You can see a video on that from previous week. Or I can do that by factoring and then averaging the x-intercepts. Since I need the x-intercepts anyway, I can eventually get to the vertex that way. So let's go ahead and get started. So I'm going to start by factoring the right side here. And I'm going to do that because when I solve for the x-intercepts, just like with y-intercepts, I'm going to plug a 0 in, but not for x this time, plug it in for y. So if I'm going to go to the factoring route, I'm going to, again, assume that y is 0, and then I'm just going to go ahead and factor that. So this is a three terms in this equation. This is definitely factoring because of the multiple x's. So I'm going to go ahead and set up my Japanese method here. Two things that multiply to get x squared. Two things that multiply to get negative 8. Let's see here. Let's do 4, negative 2. And then I'm going to crisscross this. So x times negative 2 is negative 2x. And then 4 times x is going to be positive 4x. And these add up to 2x, which is the middle term here. So I know that these are the factors. So right, top row, bottom row. So here are my factors. And again, because it's set equal to 0, I'm going to set both of those equal to 0. So here we go. So x plus 4 equals 0, and x minus 2 equals 0. Okay, so I'm going to subtract 4. I'm going to get negative 4. I'm going to add 2 to both sides. I'm going to go ahead and get 2. So these are actually my x-intercepts for that. No table to be made, especially if you can factor it. It's the quickest way to get x-intercepts, especially when it's written in standard form. So I'm going to write down negative 4, 0, and 2, 0. Now, you could, like I said, to get the vertex, you can go to the completing the square route, but there's really no point in doing that, especially if you already have the x-intercepts. We had talked about previously that you can get the vertex, or at least the x-coordinate of the vertex, by averaging the x-intercept. So I'm going to do that right now, averaging by adding them up and dividing by 2. So negative 4 plus 2 is going to give me a negative 2 over 2, which just gives me negative 1. This is the x-coordinate of the vertex. So if I were to write the vertex so far, I would have negative 1 comma something. I don't know what the y is yet. And the reason, again, this is where the x-coordinate of the vertex is because of the whole symmetry thing. These 2 points, if you put them on a number line, you can see that a parabola would, its vertex would be exactly where the line of symmetry would be. And the line of symmetry would be halfway between these 2 points. All right, anyway, to get the y-coordinate, what I'm going to have to do is I'm going to have to plug in this x value into the original equation, and that is going to be my y-coordinate. So here we go. Y equals negative 1 squared plus 2 times negative 1 minus 8. All right, so negative 1 squared is just 1. 2 times negative 1 is negative 2 minus 8. So 1 minus 2 is negative 1, and negative 1 minus 8 is negative 9. So that would be my y coordinate. So I'm going to go back up here, putting negative 9, and now I have all this key information, and if I even wanted to, I could do a really quick sketch of this graph as well, you know, applying the point at negative 4, 2, 0, negative 8, 1, negative 1, negative 9, right? And then, you know, kind of drawing a parabola through that. So again, actually a little bit better than a sketch there. Those are really the key points that you could get from a standard equation, or especially a standard form equation, right? So that's one route that you could take in these problems. Another route is maybe the problem is given to you in vertex form, right? Well, if it's in vertex form, good news, you can go ahead and write the vertex right away. So I'm going to go ahead and do that. So the vertex for this one, remember this is opposite. So it was originally at 0, 0, right? This would be a shift to the left 5. So I'm going to go negative 5 here, and then up 18. So the vertex way up here at negative 5, 18. Now, don't get confused here. Y-intercept last time I told you to just go for that last number, but you'll notice that if I plug a 0 in for x, which is what I'm supposed to do for y-intercept, that's not going to cancel this whole thing. So it's not going to just be 18. So I'm actually going to have to manually figure out what the y-intercept is. So I'm going to plug in a 0. I'm going to see what we get. So here we go. Y equals 0 plus 5 is 5, and then that's 5 squared. So negative 2, 5 squared plus 18. And then we're going to get y equals negative 2 times 25, because 5 squared is 25. And then y equals negative 50 plus 18. So that is going to be a negative, I believe, 32. And that would be my y-intercept. So again, pretty far down there. Not something that I'd really want to graph, but so 0, negative 32. There's the y-intercept. Okay, so again, as always, y-intercept, plug in 0 for x. Now, x-intercepts. Honestly, few ways to do this, but I think the best way to do this, because I'm not sure multiplying all this out, and then I'm not even guaranteeing that that'll factor. So what I'm going to do is I'm actually just going to solve this the way it is. We talked about last time that when it's in vertex form, it's actually not that bad to go ahead and get x-intercepts, especially if there is no x-intercepts, right? You'd find out very quickly. So let me show you how that would work one more time. So x-intercepts, you make y equals 0. And in this situation, I'm going to start reverse order of operations. I'm going to start with the adding and subtracting. I'd get rid of that next, get rid of that, and then deal with the parentheses last. Okay, so subtract 18. I'd get minus 18 equals negative 2. Divide each side by negative 2. Negative 18 divided by negative 2 would be a positive 9. This is looking like it's going to turn out pretty decent here. And I'm going to square root both sides to get rid of the square. So I'm going to get plus or minus. Don't forget the plus minus when you undo a square here. 3, because the square root of 9 is 3, equals x plus 5. Alrighty, so over here I'm going to write 3 equals x plus 5. Subtract 5, and I'm going to get negative 2 equals x. So there's one of my x-intercepts. And then the other one's going to be negative 3 equals x plus 5. Subtract 5, and I'm going to get negative 8 equals x. And there is my other x-intercept. So my two x-intercepts actually are at negative 2 and negative 8. So I'm going to write that down up here. Negative 2 comma 0, and then negative 8 comma 0. So that would be an example of what I could do if it was written in vertex form. Quick heads up, if you ever get to a point where maybe, let's say, for instance, you ever got to like this point, right? and you go to square root both sides, like I did just there, you'll notice that you'll get the square root of -3, which actually is not a real number. You can't square root negative. So at that point, you would just go ahead and say, whoa, no x-intercepts for this guy. There is sometimes that'll happen, especially when it's written in vertex form. So anytime, again, you get a negative square root, skip the x-intercepts because that for instance, just doesn't have x-intercepts. The graph of that might look something like this, for instance, where like the vertex is above the x-axis and the arms are up. So of course there would be no x-intercepts or something like that, right? So anyway, one last example for you. So in this example, again, it's written in standard form. So I'm going to start with the y-intercept because, again, that one's pretty easy. So that last number, there we go, y-intercept. Now, the next thing I'm going to do is I'm going to go ahead and think about, do I want to go the factoring route or do I want to go into the completing the square route? Now, when I look at this, factors at least, I'm going to break this down. The one way I could think of breaking it down would be 7 and 2, but there's no way I can, even if I make both these negatives, right, there's no way I'm going to be able to combine these to get a 6. So I already know that there's an issue with factoring here. And to be honest, I think that this is just not going to work for me. So I'm just going to go ahead and nix this one. Boink, 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 boink. I'm going to go to complete the square route. So if I'm going to go complete the square route, I'm not going to go for x-intercepts first. I'm actually going to be going for the vertex. So here we go. Y equals x squared minus 6x plus 14. I'm going to start by moving that 14 to the other side. And then I'm going to be looking for that number that kind of completes this square. And remember, it's going to be half of that number and then squared. If you look at last week's video, you can see a review on that. So half of this number is -3, and then -3 squared is 9. So I'm going to put plus 9 here. But to keep it balanced, I'm going to have to also put a plus 9 on the other side. So first off, 9 minus 14 is going to be, what was that, y minus 5? Yeah, that sounds about right. Equals x squared minus 6x plus 9. Now this, again, factors because it's a perfect square to x minus 3, x minus 3. And then again, that can be rewritten, y minus 5 equals x minus 3 squared. And then I would just have to move this guy over. So it would be y equals x minus 3, whoopsies, plus 5. All right. So got my vertex now, and my vertex is going to be opposite this, so 3, comma 5. So I'm going to write 3, comma 5 here. That's my vertex. And now it's time for my x-intercepts. So for the x-intercepts, I am going to go ahead and again plug a 0 in here for y, and then solve for x. And here is that situation, like I was saying, that's going to happen here. So we got minus 5, and this is not looking like this is going to work because when I go to square root both sides, I get a square root of a negative number, which is not real. So this particular equation is not going to have x-intercepts, and I know that for sure because of that. So I'm going to write x-intercepts. There are none. So that will save me some time from at that point on. I can just go ahead and either sketch it, but at least I know that the key points of this graph are y-intercept, vertex, and then there are no x-intercepts in this one. So there are 3 examples for you guys to go ahead and look at. Hopefully that helps you when you guys are working through the worksheet today. If you have any questions, give me an email. Other than that, I will see you next time in class. All right, bye.